rules. I like to do it with pictures, so I draw it so that you see what we are doing. So the first one that we looked at yesterday was that the angle in a semicircle is 90 degrees. The next one was that the tangent to the radius is also 90 degrees. The tangent. A tangent is a line that touches the circle. And the second one there that you learned is two tangents from the same point are equal. So that means that you have an isosceles triangle. It also means that you have two congruent triangles there where we can find the angles. We're going to use that. What does congruent mean? Same shape, same size. Right, so there's the first three. Then the next one is this one. Angles on the circumference are equal, subtended by the same arc. There's that arc there. Can you see? On the circumference, they are equal. And then the next one that we had there was that the angle at the center is twice the angle at the circumference. The angle at the center is twice the angle at the circumference. And then the next two is about the cyclic quadrilateral. So that's when you have a quadrilateral inside a circle. And there we say these two angles are supplementary. They're not equal, they are supplementary. And then you have this exterior angle here, and the exterior angle is equal to that opposite interior angle. What I do is I number them 1, 2, 3, 4, and then 1 and 3 are equal. So what we're going to do now is based on these rules. So angle in a semicircle is 90 degrees. The tangent to the radius is 90 degrees. Two tangents from the same point are equal. Okay? Now we take this two. Angles on the circumference are equal. The angle at the center is twice the angle at the circumference. And then the last two is on the cyclic quadrilateral, where these two are supplementary and the exterior angle is equal to that opposite one. So that's the rules that we work with now. So you wrote it in your book. Go back to them every time if you're stuck on a sum. Okay. So we're going to mark now. We're now on this worksheet. I tried to write the different kinds also there so that you have that. And let's start with try now 23. 23. Right, in the diagram, PR and QS intersect at T. T is not necessarily the center of the circle because they didn't say it. And remember, they will always say here on the right-hand side not to scale. So you can't take your protractor and measure the angles. That's not going to work. You need to know the rules here. Okay, so find RQS. RQS. So we have this circle. And it looks like this. Okay, so this one is 45, but this one is not the center, so that's why there's a difference now between this two here. Okay, so we can say that this one is also 45. Can you see that they are on the circumference? Those two angles are equal then there. Yeah, that can. So what I can do now is I know that this exterior angle here is equal to the sum of the opposite ones. So 85 minus 45 is then 40. So that, which one should we calculate? RQS, yeah, so the answer is 40 degrees. Can you see? Right, number 2, A. Find the value of X in each of the following figures. Now we have parallel lines, so now we can use that. Okay, so what is the size of X then? So again, we've got a circle, it's parallel lines. It's more or less the same picture that we have there. So if this one is 50 degrees, obviously this one is alternating, so that one is also 50 degrees, isn't it? And then can you see that they are on the circumference? If you can't see, turn your paper so that you can see. These two are then on the circumference. Can you see? This one and this one is on the circumference. There's the arc, so it's also 50 degrees. X is equal to 50 degrees. Right, number B. There's my circle. Okay, so this one is 68 degrees here. There it's 68 degrees. So what does that mean? This one is also, can you see, you start seeing them because there it's subtended by the same arc. Turn your paper if you can't see that so that you can see they are lying there on the circumference. Okay, and you have to calculate x. This one is now 100 degrees here, so I have a triangle, isn't it? So 180 minus 100 minus 68 is 12. So that angle there is 12 degrees. 12 degrees. Question C. There's the circle. Okay, this one is 55. This one is 34. And you have to calculate. Oh, and this one is 40. It's given that this one is 40. Which means that this little angle here will also be 40 degrees. Can you see again? Subtended by the same arc. So those two angles are equal in there. But you have to calculate x. Okay, so then we can work in the triangle, isn't it? 40 plus 55 plus 34 subtracted from 180 degrees is? I'm working in this triangle now. Yeah, this one is 40. These two are 40. But this is the triangle we're working in here. That's the triangle we're working in here. So what is 180 minus 40 minus 55 minus 34? 51, yeah. The answer here is 51. That one is 51 degrees in there. And we're looking at number D. There's another circle. Right. This one is 102 degrees, which means this one will also be 102 degrees. Look there, subtended by the same arc every time then there. And this one is 129 here. This obtuse angle there is 129. So again, you just have to work them out in the triangle. Okay, well, I got this one to be 78. It's a straight line there. So this one is 78, and then you can work in that little triangle there. Yeah, sorry, it's okay. Yeah, 51. So my answer is also 27. My answer is also 27 there for that one. Okay, and the last part of the homework was they now try now 24. So we mark now try now 24. In the diagram, now they tell us O is the center of the circle and AC is the diameter. So now those rules will apply. We've got straight lines there. They intersect at F. CDE is 25 degrees, CAE 17, find X and Y. So there's my circle. It looks like this. Okay, so this one is 17. Yes, you're quite right. X is also 17, very easy. They lie on the circumference, subtended by the same arc. So those two angles are equal in there. And this one is 25. What should we calculate? Y. So I think if you work in this triangle here, we can get Y. Can you see in this triangle? I can get Y here. Mine was 138. Is that right? Yeah, then Y is 42. Then Y is 42 there. Subtracting it from the straight line. And then the last one there, in the diagram, AEC is 25 degrees, BCD 16, find AXB. So there's my circle. There's the sketch. Okay. So if this one is 16, it means this one is also going to be 16. Angles on the circumference subtended by the same arc. I think you start seeing those ones now. This one here is 26. And I have to calculate AXB. 25, yeah. Sorry, it's not very clear. So that one is 25. So what is AXB? So what I did was to get this angle here, which is 138 degrees. 139. Oh, I took it for 26. Right. Okay, then my answer is wrong. So that one is 139. Then you can get that one, and then we can get this one that we actually want there. Can you see? So what is the final answer? 123. Yeah, 123 degrees. Okay. So now we're going to go over this was the homework up to here. So now we start with try now 25, And this is now about the cyclic quadrilaterals. So what are the two things that we know now about cyclic quadrilaterals? We know that the opposite angles are supplementary. That's the one thing. And that this exterior angle is equal to that opposite one. That's what we're looking at now here. Right, we'll do the first ones together. In the diagram, QPR is 53 degrees, PRQ 62. Find K. So what we'll do here is to first find Q. Can you see in that triangle to find Q? So what is Q? Q is 65 degrees. So this one is 65. We find it in that triangle. That's easy. What do we know about supplementary angles? They add up to 180. So this one is then 115 degrees there. Right. Number 2, there's your circle, and this time there's only one triangle in there. There you have it. This angle is 74 degrees. So that means this one is going to be, there's a straight line, so this one is then 78 degrees. Okay, so ABC. ABC. So this one will also be 78 because they are supplementary. That's the exterior angle, but they will be supplementary here. And then CED. Then I will just work in the big triangle. Can you see? I can just work in that big triangle, 28. I also got that, 28 degrees there. And then the last one is DCE. So this one. So if that one is 28, this one is 78, then my last one is 74. 74 degrees. A cyclic quadrilateral. Right, let's turn around. Number 3 now. In the diagram, so now it looks like this. There's my cyclic quadrilateral, looking like that. Right, so P is the diameter, so it makes O then the center of the circle, and SPQ is 60 degrees. So this is this one, which is 60 degrees. There is the 60 degrees. And now we have to find Y. So we can say that this one is 120. Because it's supplementary. Can you see that one is 120 then there? And then what else do we know? Come, what else can I use? Yes, that's the important thing. This one is 90 degrees because this is the angle in a semicircle. Can you see? That one is 90 degrees there. So then 120 minus 90 is 30. So this one's size here is 30 degrees. 30 degrees. Please write it in on your worksheet. You have to fill it in on that worksheet. Right, now the next one is now, try now 27. So it's about cyclic quadrilaterals. And I think we should leave that one out. We can't see. Yes. Yeah, let's just skip that. And then we go now to try now 28. Okay, and this one is about tangents. So you can see that now we will apply the 2 rules for tangents. The first one is this one. The tangent to the radius is 90 degrees. And the second one is 2 tangents from the same point are equal. But we're also going to use those congruent triangles then there. Right, so let's look at 28. I'll do 28 together with you, and then you can try them on your own. In the diagram, O is the center of the circle. So it looks like this. And here is the tangent touching here at A. You can't just assume it. They say T in is the tangent to the circle. BAT is 30 degrees. So this angle here is 30 degrees, that little one there. Now they say find AOB. AOB, yeah, so what do we know about this one? We know that this one is going to be 90 degrees. So that makes that one 60 degrees. In a circle, you always have isosceles triangles because those 2 radii are always equal. So that means that this one will also be 60 degrees there. So the top one is also 60 degrees. It's equilateral then there. And then now APB. If this one is 60, what is this one at the circumference? Half, can you see? Half the angle at the center, so that one will be 30 degrees. Right, number 2. Number 2 there. So it's the center, and we have this tangent touching it there. So immediately we know this angle is 90 degrees. Looks like that. Right, so if this one is 29, Pesci? Yeah, that's what we're going to do. No. 29 is, that's the whole angle there. So this angle here will then be 90 minus 29. 90 minus 29, which is 61. So that one is 61 degrees. But the question is, we have to find x. Okay, so that means this one is also 61. Look at that isosceles triangle that you have there every time. And what will be the angle at the center then? 180 minus twice 61, 58 degrees there. Okay, so this is how we're going to do them. I'm doing one more for you, number B. So again, there's the tangent on this side this time. Now they give you the angle at the center, which is 78, and you have to find this one, x. So what shall we do? The radii are equal, so these two angles here are equal, and we need to find that one. Is that on your calculator? So both these angles are 51. How will I get that one now? What is the other thing that I know? The tangent to the radius is 90 degrees. So what is 90 minus 51? Yeah, so that angle there is 39 degrees. Okay, I want you now to do 30 and 31 for me. 30, 31, 32. Let's quickly do those few. And then we're actually through the basic ones here. So we're looking now at try now 30. Try now 30. Okay, in the figure, so this is what we have. This is about tangents. So you've got those two tangents to the same point, to the radius, which makes those two angles already 90 degrees before we even start. The first one says now find angle OPA. This one is 15 and 7. So this is now where trigonometry is also involved. So to get that one, we will use the sine function. So sine theta is then 7 over 15. You have to use second function sine. And what was the answer? 27.8. So the angle is 27.8 degrees. This is our next topic that we will do. Then the length of OP, and OP is then, this is Pythagoras. This you did in grade 9, so it's 15 squared minus 7 squared. You can use those brackets there, then you can press it immediately. I think you learned about 4 steps. This is the shortcut now here. And what do you get? So 16.6. Okay. For that one. And then the area of the quadrilateral. Now, this is then obviously a kite, and the formula is half diagonal times diagonal. You have those 105. Yeah. Perhaps that's easier. Yeah, you can do that. Okay, question 2. So there we have another circle. It's again about the tangent. There's the two tangents coming to that triangle there. Okay. So given that PA and PB are tangents to the circle, find X and Y. So we know this one is 70 degrees. And because this is isosceles triangle, those two sides are equal. What is the size of these two angles? 180 minus 70 divided by 2, is it 55? So each one there is 55 degrees. This one is 90 degrees. So you can calculate this one here, which is then 35 degrees. Can you? No. Look at the top there. This tangent is not 90 degrees there. Here it's 90 degrees because it's the tangent to the radius which is 90 degrees. So that one there, this tangent is not 90 degrees there. Okay. So it looks like this. And there's a tangent and here's a tangent here. Okay, so this angle is 70 degrees. Let's just explain again. We can't assume that angles are equal. They must give you the information, labeling, sides, or whatever. Now here we know that it's two tangents from the same point are equal. So I know now that this is an isosceles triangle, which makes these angles 55 degrees. The second thing that I know is that this angle here is 90 degrees because it is the tangent to the radius. It must be the tangent to the radius. Here it's not 90 degrees because this tangent is there's no radius there. So that's why this angle X is 35 degrees. If this one is 136 degrees, this one here is 68. The angle at the center is twice the angle at the circumference. And then if we calculate this one, it's a revolution here. Then this one is 224. And eventually, I worked in this quadrilateral there, which is 360 degrees. And Elzine, that's how I got that angle to be 33 degrees. So that was the two answers that we have there for that one. Right, the next one. Try now 31. Try now 31. In the diagram, the circle touches the sides. So there's your circle. It touched the sides. So AB is 15. The circle is inside the triangle. It's an inscribed one there. And BC is 17. And this one is 12. So the question is now find the lengths of AT and CS. So this is still about tangents there. So we can reason that we will there have 90-degree angles. Can you see? If they come in there, you will have 90-degree angles there. So what are the sizes of AT and CS? 7.5 and 6. You just half them. Why can we say that? Because those two tangents from the same point are going to be equal. And here they will also be equal. Can you see? So that's, try now 32. In the diagram, TM, okay, so there we have a nice one now again where you can clearly see the tangents then there to the radius with the two congruent shapes. This is one that they often ask there. So MOT is 65 degrees, this one here. Now, because they are congruent, it means both of these angles will be 65. Because it's isosceles, because those two are equal of radii, that's why we can assume it this time here. And now they say find MTN. MTN. This one is 90 degrees because it's the tangent to the radius. So what is this one? 35. 25. 25, yes. And then the next one, MNT. MNT. No. MNT. So we want this one here. So it means that angle is also 25. That's then 50 degrees, so 130, divide by 2, and that's how you get the 65 there for that one. Right, then number 2, same thing here, you've got that tangent. So we'll come back to that one. There again, you've got those two there. So if this one is 27, X is obviously also 27 degrees. This one is 90 degrees. So what will be the size of this angle here? Y? 63 degrees there. 63. And look at the last one. We've got the same thing there with the tangents to the radius, where you've got these congruent shapes. Now this one is 128. Obviously this one is 90 and 90. So that angle there will be 180 minus 128, which is It's a quadrilateral. Can you see? 62. No. 52. Yes. Okay. This is one that I often ask here.
Not into sports. That doesn't mean you don't like a good cheer. Or enjoy getting out your starting block.
It's delicious.
Thank you.
Just because you don't like sports doesn't mean you can't appreciate goals.
Keep going, keep going.
A good pair of boots. The importance of a change more, a silky swing.
Well, now it's a party.
You can still revel in different kinds of defenders,
Really?
attackers, drivers, and the occasional swimmer. You can still make a good catch. Push yourself to the limit. Celebrate a good delivery and work your way up the leaderboard.
How do you sit?
After all, you don't need to take to the field to get a good dose of entertainment. We've got everyone covered with the best movies, series, docus, and more. When it comes to DSTV, you always win.
When does the magic start?
It already started.
This week on It's a Wrap.
Now my question is, what happened to the rest? There's a 300 million that's gone.
The government in power, they cannot govern us in secret and expect that we must swallow everything that is pumped out at us and expect them to be believed by us.
Do you understand the amount of money that the government has spent on the fight against COVID-19? Could they have spent 300 million on tracing people and managing people? Is that even possible?
Now, in the first place, and usually we did this in grade 10, but you didn't do it now, so this is now the new work that comes up. So the first one that we have here, I'm doing it with pictures with you. So the first rule that we have, that we call that the angle in a semicircle. A semicircle means this line is the diameter. It must be the diameter. And then it is an angle in a semicircle, and it's very strange. You can test it, but these angles are always 90 degrees. So the first one, remember, this is the abbreviation for angles. Angles, and I'm going to try to make it short, in a semicircle is 90 degrees. Angle in a semicircle is 90 degrees. So that's the first one that we need to know. Then the second two is about a tangent. Now, a tangent is a line that touches the circle at a point. And there where the tangent and the radius intersect, we have a 90-degree angle there. So the second one is the tangent to the radius is 90 degrees. The tangent is a straight line. To the radius is 90 degrees. Don't just say tangent. You're going to give reasons. Tangent to the radius is equal to 90 degrees. The tangent to the radius is 90 degrees. I didn't give you a paper because I want to draw the pictures so that you can understand it better. And then there's a second one here. So there's now another tangent there, which means that there's also a 90-degree angle there. Two tangents from the same point are equal. So that's the third one now. Two tangents from the same point are equal. Two tangents, yes, from the same point are equal. Now what happens now here is that you have then here an isosceles triangle, can you see? So that means those two angles are equal there. Two tangents from the same point are equal. Another thing that we get here are two similar triangles, remember, or two congruent triangles. Remember, we spoke about congruency and similarity. What is congruent? Same shape, same size. So here you will have two same shape, same size triangles there. They're in the middle, and we're going to use that as well. Right. Now, the next one is like this. Okay? Now, this is now where the problem comes in. This one reads, two angles on the circumference subtended by the same arc. This is what I mean with that sentence. Subtended, it means it's underneath, subtended by the same arc are equal. Angles on the circumference, subtended by the same arc. Okay, but we're just going to say angles on the circumference are equal. But this is what the subtended means. And this is what you must be able to see eventually to find those angles. Right, the next one. Right, the next one. The angle at the center is twice the angle at the circumference. Interesting. The angle at the center is twice the angle at the circumference. Angle at the center is twice the angle at the circumference. So the angle at the center is twice the angle at the circumference. Can you still see subtended by the same arc? That's what we need to be able to see. Right, and then there's two more now. So the next one is what we call a cyclic quadrilateral. So this is not a cycle. It's a cyclic quadrilateral. What does this mean? A quadrilateral inside a circle. A quadrilateral inside a circle. That's a cyclic quadrilateral. And what do you think about those two angles? No, they're not equal. Yeah, they are. Oh, yes, very good. Opposite angles are supplementary. Who said that? Yes, you can get the one. Okay? Opposite angles are supplementary. Opposite angles are supplementary. So that means they add up to 180 degrees. Opposite angles are supplementary. So these two add up to 180 degrees. Right, and now the last one. And the last one is, can you see that this is again an exterior angle? Here is that this exterior angle is equal to the opposite interior angle. Obviously, if this two is 180 and this two is also 180, they must be equal. So the exterior angle is equal to the opposite angle. So, grade 11s, we will summarize this in our revision books also later where you pasted those other papers. But I want it here because we have to refer to this now every time, every day. This is a difficult part, so you better pay attention. 360 divided by n to find the size of the angle. And Ivan? Okay, now let's just look back. Look there in your book. and make sure that you know these rules now, because you must be able to apply them. So in the first place, the angle in a semicircle is 90 degrees. Next one, two tangents from the same point are equal, and the tangent to the radius is 90 degrees. Then, okay, so let's just go back and see if we have these three. The angle in a semicircle is 90 degrees, and then we've got the two on the tangent. The tangent to the radius is 90 degrees, and then two tangents from the same point are equal. That's the first three. Okay, now we've got the next two. This is about angles on the circumference. The angles on the circumference are equal, and the angle at the center is twice the angle at the circumference. That's the next two. Look again here. Angles on the circumference are equal. The angle at the center is twice the angle at the circumference. And then the last two, cyclic quadrilaterals. So opposite angles are supplementary, and the exterior angle is equal to the opposite one. This is what we're going to use now. So keep that open in your book, and then we continue on our worksheet now, working with circle geometry. Try now 19. In the diagram, O is the center of the circle and EPF is 48 degrees. Find EOF. So which one of the rules is this one? This one. The angle at the center, you're not paying attention, is twice the angle at the circumference. So the answer is 96. That's right. Try now 20. In the diagram, O is the center of the circle and LPM is 150 degrees. Find the reflex LOM. Why? Because the angle at the center is twice the angle at the circumference. If you can't see them, turn your paper. Okay, then number 2. In the diagram, O is the center of the circle and YOK is 120 degrees. Find JPK. This is the center, this is the circumference. You shouldn't take 120. What should we take? Yes, that's right. Look at this one. Look at this one. So this one here is 120, but we have to work with this one with a 240 here. So then to get that one, which is half of that one, it will be 120. The answer now is 120. Okay, next one. Let's continue. Page 8, 7. So it's still the center. This is the two rules that we are looking at now. Try now 21. In the diagram, O is the center of the circle. MP and LN intersect at right angles at Q. And OMQ is 24 degrees. Find MPN. Please take a highlighter in your hand and mark these angles now. Take a highlighter and mark these angles. So what is the size of the angle at O? We first have to find that angle at the center. Can you see? Because that's the only way that you will be able to find the other one. If you first find the angle at the center. This is what we're looking at. So there is the circle, and this angle here is now, it looks like this. So this angle here is 66 degrees. But what will that one be? The angle at the circumference is half the angle at the center. The angle at the center is twice the angle at the circumference. So what will that one be at the circumference? No, half of it, 33. Yes, 33. Half of it. Half of it. The angle at the center is twice the angle at the circumference. So if you put it the other way around, the angle at the circumference is half the angle at the center. The rule is the angle at the center is twice the angle at the circumference, subtended by the same arc. 22. In the diagram, now here we also have parallel lines. KL is parallel to NM. KL is the diameter of the circle, center O. Con is 54 degrees. Find KLM. KLM. Now, this time, we can't say it's 108, because it's not. Can you see the one is the one's arc is km, and the other's arc is kn here, and the other one is km. So you cannot just say that L is 108 degrees. But we work with the parallel lines. So use your parallel line effect. Yeah, it is a quadrilateral, and it's parallel lines in its alternating angles. So this one here at N is 54. This one here is 54. Alternating angles with the parallel lines. And then, yeah, because it's opposite in a parallelogram. Can you see? So that one is then also 54 degrees. Yeah, but they just want KLM. They just want KLM. Okay, it forms a parallelogram. Remember, the radii of a circle is also always equal. So that's what we use here to see that it's a parallelogram. Right, now number 2. Look at number 2 there. In the figure, O is the center of the circle, AB is parallel to DC, and AOD is 58. Find the angles marked X, Y, and Z. X, Y, and Z. So you have that one angle at the center, which is 58. What would be Z? So the one angle here is 58 degrees. Here, 58. And it's parallel lines, which makes this one also 58 degrees. What about the angle here above Z? Okay, let's just look a little bit. Try a little bit here. Can you see that this angle here will be 90 degrees because it's the angle in a semicircle? Can you see that one? It's the angle in a semicircle. It's good to label them out what you know. We know that this one is 58 degrees here at the center. This one is 58. So that one is 58 degrees, which makes this one here at the top also alternating 58 degrees. Yes, good question. Look at what this started. It said O is the center of the circle. That means AB is the diameter. So that means that angle there is 90 degrees because this one is the diameter. So because they said O is the center, that's why you can assume that. That's why we can say that. What is the size of X, Y, and Z? But you can't use that one on the circumference and on the center because, again, your arc, that arc. Okay, so let's look at this question on your worksheet then. This is then the revision of circle geometry there. The points A, B, and C and D lie on the circle with AC as diameter. That angle C there is marked as X. That one is marked as X. Find angle CBD. Now look what they do now. Now they say in terms of X. That means you cannot get a value. It must be in terms of X. So what do we realize? I realize that this one is 90 degrees because that is the angle in a semicircle. You must mark them now so that you can see it. So in this triangle, this angle will then be 90 minus X. 180 minus 90 gives you 90 minus X because I can't get a value. It is in terms of X that I'm going to give this. Then number B. The radius of the circle is 5 and the length of the chord is 4. So that one is 4, and so I calculated this one, and then they are on the circumference subtended by the same arc, so that one is still 90 minus X, that angle there. Now we have to work in this right angle triangle. We know that this one is 4 and this one is 10, because the radius is 5, the length of that side AC is 10. So to calculate, so this is now again trigonometry. We're going to find this now every time a problem. So I would say cosine X is equal to 4 over 10. So we press our calculators, second function cosine. Look on your calculator. There's that button, second function, shift, second function cosine, 4/10. So x is, and angles is always to 1 decimal place. Angles is to 1 decimal place. Okay. Question 2. This was question 1. So again, we have a circle there. There's the circle. Okay, that one is again x. This one is 53. We have a tangent there. Oh, a tangent there. This is z. This is y. So we know that this angle is 90 degrees there, which makes x then 37 degrees. X is 37 degrees. We also know that this angle here is also 90 degrees because it's the angle in a semicircle. Can you see that one? The angle in a semicircle. Okay, so what is the size of y? If this one is 37, 53 again. So y is 53. And then in the triangle, 90 minus 37 minus 180 minus 90 minus 37 is 53. Can you also see that this one is the exterior angle and this is the interior angle there? So you can also use that fact. And now the last one is to get z. What would you say is z? What is z? What is z? But you're supposed to work on your question and label the equal marks. Z is also 37 because it's subtended by the same arc there. It's subtended by the same arc, that one there. Right, question 3. Number 3, it's a pentagon that you have there, and we have to find those angles there. So there's the pentagon. Okay. Now, this is polygons, so the questions are mixed now here. We have to calculate DEF. So it's in a pentagon. What do you know about a pentagon? But what do we know about the AEF is the exterior angle. For polygons, you've got 2 rules, interior, exterior. So this angle here is exterior. What is the rule, Jan Ivan, for exterior angles? No, that's interior. 360 divided by 5. So what is the size of this exterior angle? 72. And then DA, okay, so obviously this one is then 108. You can get it with interior angles or you can subtract it from 180 degrees. Okay, and then DAE. So what do you know now? DAE is now that angle that we have to calculate there. How will you do that? We have an isosceles triangle, so it will be 180 minus 108 divided by 2, which is what? 36. Okay. So this one that looks like 90 degrees will also be 108 minus 36. Okay, so it's not 90 degrees there. No. No, because it will be 108 minus 36, which is what? Also 72. Yeah, it will be 72. We said this is an isosceles triangles because it's a regular pentagon. It's isosceles. So 180 minus 108 divided by 2. That's how you get that one. Right, question 4. The diagram above shows a regular seven-sided polygon. Each of the interior angles are marked with X. No. How do we get interior angles of a heptagon? N minus 2 times 180. Right.
September's all about fresh. Look fresh with the hottest tat crew in Compton. It's all about fresh drama as a family goes to war over money in this first of its kind telenovela. And sing along with the freshest reality as we go behind the scenes to Sauti Soul's success. Get fresh and stay fresh with DSTV.
Namibia is known for its beautiful wide open landscapes. However, these deserted spaces also pose numerous educational challenges in our country's rural areas. Because of this, many learners are denied access to proper teaching and learning. At Eduvision, we believe that education is the starting point to a journey of endless possibilities.
Soon and very soon, we are going to see e-learning. Soon and very soon, we are going to...
The plan for Eduvision was to identify areas in Namibia that do not have the proper learning resources, a working school or an education center.
Hallelujah, hallelujah, we are going to see e-learning. No more.
My name is Philip Smith. I'm the principal of Educate Academy in Otjiwarongo. The project Eduvision, the e-learning program, started in 2017. With a project like this, obviously telecommunication, internet connection is a major thing that needs to be sorted out, a logistical challenge. And the fact that we chose Chunkwe Secondary School as the first school didn't make it easier for ourselves. It's very far from Otjiwarongo, it's far from Windhoek. So the internet connection was a big challenge first of all. So with the help of the telecommunications expert Paratus, they made this dream come true with internet connections via Windhoek, Otjiwarongo to Chunkwe and then back, the whole process. Like I said, it's interactive whiteboard, so the internet speed, capacity of the connectivity and so forth plays a major role. And so Paratus made this dream come true, and they were on board from the first moment. So very grateful for Paratus.
The project offers teaching assistance of a high standard in science to rural secondary schools within the learner's own community by means of e-learning. This entails the following: live transmissions of lessons from an equipped teacher in a different location to the students in rural areas, students using their own cell phone, tablet or computer to recall each lesson, and interactive lessons as well as the use of a smartboard as a teaching aid.
So if you look ahead at the next 3 years, we get information from the Ministry of Education. The future is very bright. So I think there's a lot of schools who can benefit from this program. Like I mentioned before, finances obviously plays a major role in a project like this. So we're very thankful for all the sponsors that are on board and still on board after almost 3 years of the project. So as long as people from the private sector can get involved, I think we can reach many schools in Namibia, because this project made a good start now. We're already seeing some positive results, and we can just call on all the private sector, corporate sponsors to come on board and join in this very, very positive project.
It is Eduvision's goal to prepare and guide learners in order to make the modern world they are living in accessible to all.
My name is Magdalena Neoma. I'm 18 years old and I'm doing my first year at UNAM Command campus, and I completed my grade 12 at Tsongwe Senior Secondary School. I'm doing education, so I'm gonna teach at Tsongwe Secondary School because there I really need to go there and motivate the learners. Eduvision helped me a lot. It assisted us in teaching for mathematics, physical science, and biology. And it also, we get to exchange learning from other schools like Educate, whereby they teach us, and that's the most thing that we benefited from. Studying without Eduvision was so challenging. And when Eduvision was introduced at our school, things become more easier. The time where Eduvision was not introduced, we were so slow in learning. And when Eduvision introduced at our school, my learning speed increases. Things were kind of boring. And when Eduvision came, my mind changed the way I think. I'm really grateful for what Eduvision gave us. Our class of 2019 was the first group to make it, to perform very well at Tsongwe Senior Secondary School. So it should keep up the spirit. We need that. It should continue to support us.
Eduvision aspires to ensure that equal opportunity is offered to every learner in rural areas to tap into his or her own potential while working in an environment which views disadvantages not as obstacles but as unique attributes that can be regarded as powerful assets when given the proper opportunity. At Eduvision, we believe that dreams are the foundation of knowledge and hope always triumphs over experience.
No more problems. Everything is proper.
I'm one of the few who's privileged, to come from different cultures, come from a Kenyan culture, be embraced into a Namibian culture and manage to blend both of them and understand how it is to be that multicultural